All right, go take your homework out if you would, please. Books open to page 145. Page 145, you did numbers 33 and 35. Just a couple problems, just enough to try to keep your brain sharp and ready for what's coming up later on in the hour. Page 145, numbers 33. I'm looking at the shoes there, Ethan. Jamie, you can't see the shoes, but they are purple with orange and green dolphin accent. Just dolphin colors.
I like them.
You got the purple, so it's like dolphins and ravens.
Here, Ethan, take off your shoe.
Look at my socks.
And we've got strange-looking socks to match. All right. Page 145, numbers 33 and 35. Number 33, I thought was pretty straightforward if you just follow the steps that you've been given. With the cosine of gamma minus the sine of 2 gamma is equal to 0. And I told you that anytime you got a single angle and a double angle in the same problem, you gotta do what, Chris?
Get rid of the double angle.
Get rid of the double angle. So how do I replace, or what do I replace sine 2 gamma with?
2 sine cosine?
There we go. 2 sine cosine. Once we've done that, now we just go back to what we were doing in the last section. This is stuff we've done for the last week and a half now. Quentin?
Pull out the cosine.
I got multiple trig functions here, so they're already set equal to 0, a factor. You said pull out the cosine of gamma, and that's going to leave us with
1 minus 2 sine.
And once we've set it equal to 0, well, it already was set equal to 0. Once we've factored, Ethan,
Set equal to 0.
set what equal to 0?
Cosine gamma and 1 minus 2 sine.
Good, set the factors equal to 0. And that'll give us two little equations.
Cosine gamma equals 0 and sine gamma equals 1/2.
Thoughts, anyone?
Put the 0 over 1 positive negative. So if you have a 0, it's always, and you put it over 1, it's always going to be positive negative.
Yeah, anytime we see a 0, we're always going to put it over 1 so we can see the ratio a little bit better. Unless you're a unit circle person, then obviously you're just like, well, when is the cosine line 0? But if you're a triangle person, which I think most of you are, putting it over 1 helps you to think adjacent over hypotenuse. And the positive negative reminds you, whatever you get for your angle, do the opposite of it. You know it's going to be a quadrantal, because 0 is only in a quadrantal triangle, but don't forget to do the opposite of whatever you get, whether it's 0 or 90, do the 180 or 270. So when is cosine 0, class?
90.
90, so I want both.
90 and 270.
All at 0.
So again, be careful when you draw your triangle.
Yep.
Here's the 0, here's the 90, here's 0, 1, 1. I've got adjacent leg, or excuse me, adjacent leg here, and then hypotenuse here. And so that's got to be the 90-degree angle. All right, what about sine as a half? When is sine opposite over hypotenuse 1 over 2?
30.
And it's positive here, so only
30 degrees 150. So what?
first and second quadrants, 30, 150. How many had all 4 correct answers?
Oh, I didn't have the 90.
All right.
I had 0 and 180.
We had 0, 180, so just be careful with the reference
I
angle.
thought we had to square everything. I forgot about the double.
Yes. Yeah, now I will say this. If this isn't a double, then yeah, our only option is square everything and hope for the best, right?
But you would only get 1 equals 0, which is what I got, and I was confused.
Well, careful. If you're going to square everything, we can square the first, square the last, multiply, and double.
Oh.
So, yeah.
Yeah, that's not going to be on the quiz day, is it?
You never know.
You better hope not.
All right, let's go ahead and, what quiz? Let's go ahead and take a look at number 35. The other problem you had for homework, and this problem, again, is a change from what was in my book originally, cotangent 2 tau. Is it negative square root of 3 over 3 in your textbook?
Yes.
Okay, that's a lot easier when they originally had. They're going soft on you. So for this one here, there isn't double and single, it's just double. So we just roll with it. Ethan?
Tangent is reciprocal tangent. Cotangent is reciprocal tangent. So for
Okay.
double angle.
So in that case, we could say tangent 2 tau, and we could take the reciprocal. What is the reciprocal?
3 over square root of 3.
Well, negative 3 over square root of 3, which if you then rationalize the denominator, it would end up giving you what?
1 over square root of 3.
How about that? Or You could just say this is the rationalized form of 1 over square root of 3. And instead of thinking opposite over adjacent, you could just say adjacent over opposite. I think that's probably the more direct approach, frankly. Not that it's wrong to think in terms of the reciprocal, but I think it's a little quicker just to say, hey, this is the rationalized form of this. It's adjacent over opposite. When is adjacent 1? When is opposite square root of 3 class?
30 degrees.
60.
Well, because I typed it in my calculator as negative square root of 3 over 3 and took the arc tangent.
But that's we need our cotangent.
Oh, wait,
So what you would have had to do is type it in the calculator, take the reciprocal, then take the arc tangent. So that's why you got the 30. So you should have had 60 for the reference angle. And it's negative though.
So quadrant 2 and 4.
2 and 4. So that means that 2 tau is going to equal 2 and 4.
120 and 300.
But since there's a 2 tau, what do I got to do, Chris?
360 divided by 2.
Add the 360s, right, to get...
480 and 660.
And then divide everything by 2 to get 4 different answers here.
60, 150, 240, 230, or 330.
And there are our answers. Do we get these answers for this problem?
Well,
Okay, I thought this one was really
so-
pretty easy. Questions?
So, could you change the doubling or whatever to like the reciprocal of the doubling?
That's what I did.
Like
Oh
so
my.
1 over tangent.
Whew. All right, so
I'm just wondering if you could do that.
That's what I did.
all right,
I
so
tried
we're
it.
thinking since tangent double angle. I'm not sure if this is a great idea, but let's try it. Tangent double angle is 2 tangent over 1 minus tangent squared, right? So since this is cotangent, I don't know why I picked gamma that time, we'll flip it, right? So it'll be 1 minus tangent squared tau over 2 tangent tau equals negative square root of 3 over 3. You would have to specify that tangent of tau can't be 0. And then I guess you could try to cross multiply. Oh goodness. Negative 2 square root of 3 tangent tau equals 3 minus 3 tangent squared tau. And you're like, well, that's a quadratic. Let's set it equal to 0. 3 tangent squared minus 2 squared of 3 tangent minus 3 all equal to 0.
I'm sorry, y'all.
And now you're trying to simplify. Oh my.
Yeah, how do you do that? Like,
Well, I would say this. You got a radical. So here's, I guess, where I would go with this. I'd say, well, you have a radical. And if you got a radical, square both sides. And that would give you positive 4 times 3 tangent squared tau equals 9 minus 18 tangent squared tau plus 9
Oh my
tangent to the
goodness.
4th tau. Wouldn't it just be easier to do it like this?
can you finish that? Can you even do anything?
For sake of time, I'd rather not.
Alright.
Good night. Well, now I'm curious. All right, so set it equal to 0, 9 tangent to the 4th. Bring this over to negative 12 to get negative 30 tangent squared tau minus or plus 9. I divide everything by 3 to make life a little easier.
This is the Gwen
3 tangent to the 4th tau minus 10 tangent squared tau. Jamie's fast forwarding past all of this right now. Plus 3. You could backwards FOIL and get 3 tangent squared and tangent squared. Signs are both negative 3 and 1. So it gives us that tangent squared is equal to 3, and it gives us that tangent squared is equal to 1/3. That means that tangent tau is equal to positive negative square root of 3 over 1, and tangent tau is equal to positive negative 1 over square root of 3. But,
I did something like that, but it was a lot shorter.
so this is going to give you, watch, this is going to give you 60, 120, 240, 300. This is going to give you 30, 150, 210, and 330. Now look at these answers. They're here as well. But you have to check every one of those because you squared both sides. You've created extraneous roots. That's extraneous, that's extraneous, that's extraneous, and that's extraneous. So not only does it take longer to get the answer, you then have to check all those answers. But the easy way would be to look at it and say, cotangent, when is it square root of 3 over 3? I don't have a triangle like that. Oh, it's a rationalized form. 1 over square root of 3. Adjacent over opposite, that's 60. Negative 2 and 4. go around again, add 360, divide everything by 2, we're done. We don't even have to worry about checking. Yes, sir.
See, what I did is, I did the reciprocal double angle of the tangent, and then I changed the negative square root 3 over 3 to negative 1 over square root 3. And then I cross multiply, and then
Still sounds pretty hideous.
Yeah.
since it would be square root 3 minus square root 3 tangent squared, I took the square root of the second square root 3, and
You factored it out.
yeah.
Did you get the answers?
Well, I got 2 of them, but I think if I finish it, I would get all 4 or 8.
Does this seem easier?
Yeah.
Let's do it this way.
Oh, I mean,
Yes.
that's the way I thought
So
of it.
say you have 4
Extraneous roots.
No, say you have 4 like just the answers, and or is it always going to be half of them going to be extraneous?
No, very rarely will half be extraneous. That's very odd that it worked out that way. Usually there's only 1 or 2 extraneous.
You were surprised.
Well, I've never worked it that way.
You're like,
Never would have thought to.
Never want to work
How is that easy?
When you check that, can you put it in the
You go back to the original. Well, you'd have to go back to the original, but you would take the reciprocal. So you would say the tangent of 2 tau equals negative 3 over square root of 3. And so you double every one of those angles, take the tangent, and see if it gives you that value. You figure out what the decimal is, save it in the memory, and so you double each of those angles and double take the tangent. Does it equal that? Double take the tangent. Does it equal that? Double take the tangent. Does it equal that? Double, and over again. All right, we need to move on for sake of time. Number 14 in your textbooks. You're open to page 145 already. Jamie, if you were fast forwarding, now's a great time to rejoin us. I wasn't fast forwarding. I was laughing at Ethan.
I was just wondering if you did.
No, it's great. It made me think. It gave me a chance to be a nerd. All right. So we got the sine squared kappa over 2, cosine squared kappa over 2, spelled K-A-P-P-A. Cotangent 2 kappa equals 0.
That's a lot of
Oh
time.
my goodness.
All right. Well, first of all, I see half-angle identities. Half-angle identities are ugly, but I also notice that the half-angle identities are being squared. So what is sine's half-angle identity class?
Square root of 1 minus cosine over 2.
Good. Positive, negative, square root of 1 minus cosine kappa over 2. But it's all about to be squared. With cosine, again, it's going to be squared. What's cosine's half-angle?
Plus minus square root of 1 plus cosine over 2.
And of course, cotangent double angle. Cotangent double angle. We just looked at that, right? And we said it's the reciprocal of tangent's double angle. It's going to be this. And yes, because I have half angle, which is going to become single angle, and I've got double angle, I just got to simplify it all down. I can't keep half angles because of the double angle. I can't keep double angle because of the half angle. So we're also going to rewrite this as 1 minus tangent squared kappa over 2 tangent kappa. Just the reciprocal of tangent's double angle. You're doing this with me. Now, here's the nice thing. Square roots are being squared. So,
Cancel. Yeah, get rid of.
and when I do, it's all being multiplied, right? So if I multiply across the bottom, because that's where it's easier, I always do the easy stuff first. 2 times 2 times 2 tangent kappa.
8 tangent kappa.
And in the numerator, I've got a 1 minus cosine kappa. I've got a 1 plus cosine kappa. And I've got a 1 minus tangent squared kappa. Catch up while I'm erasing. If I lost you, ask a question. Everyone still with me, following what I'm doing?
Mm-hmm.
Okay. I created a fraction by doing this.
So tangent can equal 0.
Good. 8 tangent can't equal 0, but that just means tangent can't equal 0. Okay. So, now what?
1 minus tangent 2 is a Pythagorean coming in.
1 minus tangent squared.
Mm-hmm.
And 1 plus tangent squared is Pythagorean. Not 1 minus tangent squared.
You know what I want to say.
What do you want to say?
I don't
Come
want
on.
to say it.
Say it,
Square
Glenn.
it.
I don't think I want to say it.
Square it.
He's like square root.
No, we're not going to square it. Well, here's the deal. I have a fraction equal to another fraction.
Cross multiply.
Let's cross multiply. Here's the beautiful thing. A tangent kappa times 0 equals
Zero.
0. And all of this times 1 equals all of that. But rather than copying it as is, do you see right here 1 minus cosine, 1 plus cosine? What is that? It's a sum and difference, which is going to give us a, if we will do 3 things.
Square the first, square the last, put the minus sign in between.
To get
1 plus, or 1 minus cosine squared.
1 minus cosine squared kappa, and then we're going to keep the 1 minus tangent squared kappa. And so I've got 2 factors set equal to 0. Set them both equal to 0. To get what?
Cosine equals
positive 1.
Good. Cosine squared equals 1. Take the square root. Cosine equals positive negative 1.
And tangent equals positive negative 1.
And the same exact thing is going to happen here. In both cases, let's put them over 1. So again, on the surface, you'll look at this like, oh, that's hideous. Well, just follow the steps through. Write out the identity, square it, that cancels the square root. Write it out, square, that cancels the square root. Write it out as the flipped tangent identity, and then multiply it all together. Now, not actually distributing into each other, foiling or anything like that, but because it's equal to 0, that denominator, when it's cross multiplied, drops out anyway. That's going to be really nice for us. All right, so when is cosine 1 over 1? Think carefully before you answer.
0.
Yeah, 0.
0. Positive negative tells me kappa is.
0, 180.
All right, when is tangent 1 over 1?
90. No, 45.
45. Positive negative?
So all of them. So it'd be 45, 135, 225, and 315.
Jamie'd be like, slow down. She could pause.
I'm just too fast for you.
All right. Now, do I need to go back and check everything? No. I only need to check and make sure that the tangent of these angles doesn't equal 0. Well, all of these angles, because we already know the tangent equals 1. So I'm not even worried about those. Would the tangent of either of these be a 0?
Tangent, the 0.
Ooh, so 0 is extraneous.
And same for 180.
And same for the 180. Okay. So we end up only getting to keep the 45s. And there's our answers. But that's why we have this qualifier. So we'll remember to go back and check our answers. And we did. And we found a couple extraneous in there. Questions on number 14? Take a look at another one here. Number 36, excuse me. Number 36.
Gotta get rid of the double angle.
Yes. So Ethan, there's kappa again.
Yeah, I hate kappa. Sounds
It's
like
just a K. It's got
that sounds like a
just
Pokemon. Equals 0. Cotangent does equal cosine of a sine.
It does. But I thought you said we were going to get rid of the double
Yeah,
angle.
we got to. 1 over sine, or sine over 1.
But it's a double angle. What's
I know it. 2 sine angle over, or 2 sine angle cosine.
2 sine kappa cosine
I'm trying to figure
kappa.
that out too.
By the way, I do need to make a qualifying statement here, class.
Sine can't be 0.
Sine kappa can't be a 0. All right. Now what, Ethan? Kind of on a roll there. Or I'll have Chris bail you out. You don't want that.
Would you put it over 1?
Sure.
You couldn't cancel the signs.
I can't because they're not being multiplied. Good. Can't just cancel.
Put it over sine, all the whole thing over sine.
I could, but remember in an equation when I have fractions, I hate fractions.
Multiply everything by LCD.
Right, let's multiply everything by sine. What do we get if we multiply everything by sine?
Get 2 sine
Here we go. Guys thinking the same thing?
I'm already ahead, yeah.
Good, good. All right, then what?
You take out a cosine.
Good. Starting to fall more into the pattern we're used to seeing.
And then you can send me 0.
Well, 2 sine squared kappa plus 1. There we go.
Send me 0.
All right.
And cosine kappa is 0. And then sine kappa equals. Oh, 1 over square root.
Be careful. When you move the 1 over, it becomes
A negative. So
negative 1. You divide that by 2, and then you take the square root. Thoughts? You have to pull out an I. You can't take the square of a negative. So this is positive negative I times 1 over the square root of 2, but we don't do imaginary.
Makes my job easier.
It sure does.
Cosine kappa equals 0 over 1, positive negative. And that's 90 and 270. I'm gonna check and see if it's.
Right, let's make sure. Does the sine of 90 equal 0, class?
No.
What about sine of 270?
No.
Okay, then we do keep these answers here. Questions on this?
I had already finished it.
Good. Got those same answers? Excellent.
I'm glad I thought about it.
You set your books aside, keep your notes out.
Oh,
We do have a quiz coming up in just a few moments, as most of you have already figured out,
in wailing gnashing of teeth.
etc. And so, got a couple review problems for you here. Go ahead and solve those.
I'm about to say that equals 1, but it doesn't.
Questions on the first one?
I got it right.
Yeah, as I was working, I was like, if only this had been a negative
Yeah.
right here, then this would have been a positive 1, which would have been positive negative 1, and it still would have been 0 and 180 for my answers. It would have been some duplicates, but still, you know.
I made a job easier though.
I got the exact same thing.
Working on the next one.
Already done.
Already done with the next one. Working on this one.
Oh, there's another one.
Quentin, are you good to go on this middle one?
Yeah.
I'll go to erase it and put one more up. And Jamie, if you weren't good, rewind. Rewind math class, fast forward math class. The things you can do on video. Just can't ask questions. That's the moment.
Is that one right there, is there an actual answer to it?
We'll find out.
I don't think so.
All right, looking at that one on the far side of the board, the second one that I put up, we see we have to apply the double angle, right? But cosine has 3 different double angles. I actually realized this wasn't the best one to use. I should have said cosine squared minus sine squared plus sine squared equals 0. Why?
Because the sine squared.
Because the sine squared cancel. My thought was I didn't want to introduce cosine and sine, but it just hit me. Wait, that would have canceled. And I'll literally get cosine squared equals 0, which would give me cosine lambda equals positive negative 0 over 1, which would have been 90 and 270 anyway. As was, I did the 1 minus 2 sine squared. As long as I don't do 2 cosine squared minus 1. That's, I guess, the only form you wouldn't want to use. But that would have been quicker.
What I did was cosine squared minus sine squared plus sine squared.
Well, no, cosine squared minus sine squared is the double angle.
Yeah.
And then you have the plus sine squared, and that gets you to that.
Yeah, but I ended up pulling out a sine, negative sine squared.
Oh, no. You just cancel them, right? Like if you had 3
I thought you
plus
said
5.
cancel.
Well, it's not that you're not canceling as in dividing them away, but they are inverses. They have to cancel each other. You're just adding like terms there. Like negative and positive 5 cancel, negative sine squared and positive sine squared cancel.
Okay.
All right?
Yeah, but I still ended up getting 0 and 180, so I still ended up getting an angle.
No, it should have been 9270 here. All right, questions on this one? Ethan, you good to go now? Quentin, good? All right, Jamie, if you're not, rewind.
Don't care what you're doing.
Oh, we love Jamie, but, we're moving on. Like Brian Kelly. Oh, but it sounds like we're going to promote our defensive coordinator.
We got to get rid of, what's his name? Bill O'Brien. Alabama.
Yeah.
He's so bad. I just want to get rid
We
of
need
him.
our offensive coordinator? Or is your DC?
I think he's our DC.
We need to get rid of both of them,
Both of them are bad. They can't protect Nick and Bryce Young. If we can protect Bryce Young, we'll be okay. But we
Well,
can't.
good luck against Georgia.
Yeah, the best defense in the
Their
nation.
best defense, but your offense is not that. It's not that good.
All right,
Our offense is 15th.
Do what?
Offense is 15th in the nation.
Yeah, ours is pretty good, but it's just our defense. I'm worried about. But,
Oh, there was an answer to that.
yeah, it's easy. Oh my god, that was right. I think I did. Oh, I forgot to double the other two.
Uh-oh.
No, I had 120, 240, 480, and 600. I just forgot.
Got to cut them all in half.
Yeah.
Questions on this one? Should I get rid of the double angles here?
No.
No, because I don't have any single angle. But what should I do here?
Move the cotangent to gamma over is a negative.
Right. You don't have to get rid of a double angle, because it's all double. But you do have to, since you have multiple trig functions, set it equal to 0 and factor. Thoughts?
I do. Well, I didn't do the right thing there. Because I didn't move the negative square root of 3.
How about cosine over sine? Because now you can factor something. We do need to make a qualification though.
Sine cannot equal 0.
Sine of 2 gamma can't be 0. So none of our doubled angles, if you took the sine of the doubled angles, can equal 0. But we can factor. What can we factor?
Cosine 2 gamma.
Take it from here at your seats.
We're not going to have one like this on the quiz.
You hope so.
I hope so, because I'm getting that one wrong.
I say it's pretty basic algebra.
Yeah, it's just a lot to remember. So when there's fractions and you factor, I always.
Well, you could multiply everything by sine. You could do that instead. We want to see it work that way instead.
That's fine.
Multiply everything by the LCD.
I'd rather have done that. That's what I would have done.
All right.
Okay.
Because let's face it, that's usually what we do in an equation anyway, right? We see fraction, we hate fraction, multiply everything by the LCD. Let's do that. Let's multiply everything by a sine 2 gamma.
Watch it not work.
Oh, it will.
Oh, that's not what.
All right, so that gives me 2 cosine 2 gamma sine 2 gamma minus square root of 3 cosine 2 gamma equals 0. That's pretty easy, right? And now we factor out the common factor, which is still
Cosine. Double angle.
cosine 2 gamma. What are we left with when we take out the cosine 2 gammas?
Sine squared gamma.
No.
Or
2 minus.
2 minus.
So
Three.
2 sine 2 gamma minus square root of 3.
Oh, he does way better.
No, I don't.
And now we make 2 equations,
Yeah, that's not bad.
which are
Cosine double angle equals 0. And then sine double angle equals square root of 3 over 2.
when is cosine 0 over 1?
0 degrees.
90.
90, positive, negative.
90 and 270.
But,
Yeah, double it. 360.
not double, but add 360.
Yeah, that's not bad.
450. 630.
630.
All right, hold off on this for a minute. Down here, when is sine square root of 3 over 2?
30, 60.
And since this is quadrant 1 and quadrant
2.
2, 60 and
120. 360.
add the 360.
420. 40.
Now hold that thought. Before we go any further, remember the sine of any of these can't be 0. Well, we know the sine of these is square root of 3 over 2, right? But what about the sine of these? Would the sine of any of these doubled angles equal 0? Does the sine of 90 equal 0?
No.
Or 270?
No.
And these are just coterminals, so they're going to be the same thing anyway. Okay, so we're good. Now let's go and get all of our gamma answers. Divide every one of them by 2.
45, 135, 225, and 315. Now on the bottom you have 30, 60, 210, and 240.
like.
Okay, here we go.
That was fast, man. I'm good.
Questions?
Clear your desk.
Clear your desk, except for clean sheet of paper, pencil, calculator, everything this way. First and last name at the top of your paper, along with today's date, which is 12/2/21. 12221. First and last name at the top of your paper, today's date, 12/2/21. Jamie, you will take this quiz when you return, of course.
What quiz is this?
And this is quiz 22. Here on 12221. Quiz 22.
1, quiz 22.
There we go, lots of twos.
It's cursive.
Pretty straightforward. 4 equations.
Here goes nothing.
Solve them. Very similar to last quiz. Just 4 equations. Solve them. All right, the homework on the chalkboard. So the video will end here for Jamie's benefit. And